Biological systems are much more than the sum of their parts. Biological system, for example, like the digestive system or the cardiovascular system, or even the whole organism as a whole, it works better than if it were by itself. For example, if you have just the heart or the brain alone, it doesn't work. You have to have the whole thing. Or you have a cell. That's why eukaryotes, humans or animals, were multicellular. We don't function, our body parts don't function by themselves. They have to be part of the whole thing in order to work. And that's what I mean by biological systems are much more than the sum of their parts. So just the part alone doesn't work. It has to be all together in order to make it work. So the property of a heart, it's a function to keep the blood flow, but the heart by itself doesn't work. So therefore it has technically no property. But when it's inside a whole system, like the cardiovascular system or the whole organism, it starts to work. It has a new emergent property. It's a property that just emerge out of nowhere because it works together as a whole, but by itself it doesn't work. Another example is like computers. If you take all the little chips and stuff by itself, it's not very active, it doesn't work. But when you put them all together, then it becomes a working computer. One example that doesn't apply, for example, is opposite. Let me give you one that makes sense so you can see the opposite. For example, like a table in a house. The table inside a house, it works as a table, but a table outside the house, it still works as a table. So you see, it doesn't apply for that. It applies for biology. So that's the difference right there. Now when scientists are studying about biology, they're faced with a dilemma that because of the fact that it only works as a whole, how do you study small stuff like cells and organs and heart? Like if you take it out from the organism, it's not going to work anymore. So that's the problem. But in order to study about it, you have to dissect the organism. You have to look at the smaller cells and such in order to make it work. So how do you look at something and then make sure that it works, but at the same time you're faced with a problem? If you take it apart, it's not going to work. So thank goodness for modern day biology, because we have a new technique called reductionism, which is the ability to reduce complex systems to simpler components that are more manageable. And that's modern biology for you. So everything you find in a textbook, it's luckily we have modern biology to make it easier for us. We don't have to go through the whole process.